So we studied about the dynamic allocation problem, that is how to satisfy a request of a particular size of the size of the process from the set of free holes that is available in the memory, right? The set of free holes will be searched to determine which hole is best to allocate for the incoming process, right? So that was about dynamic allocation of the memory as and when it is requested by the process. So operating system will find out the memory requirement of the process which is waiting in the input queue, and again it will search into the list that operating system is maintaining. The list contains the set of free holes, right? So it will allocate the one which is best suited for the process. Okay, so there are three strategies which are most common that use to allocate the free space. Okay, and this particular strategy is trying to allocate a free space, okay, of incoming block. So if we talk about replacing the block which is already present, no, it will find the empty space, empty region, and it will fill up this empty region with the process which it has requesting. Okay. So according to the requirement, there are three strategies. These strategies are called first fit. Second one is called best fit, and the third one is called worst fit. It is called worst fit, right? So in the first fit, the operating system will allocate the first hole that is big enough for the process, right? Allocate the first hole that is big enough for the process. Okay, so once the first big enough hole is found, then it will stop the searching as soon as it find the hole that is large enough for the process. So first fit allocation scheme will allocate the first hole that is big enough for the process, and after which it will stop searching. Okay, everyone. So where were we? I think we were up to first fit, best fit, and worst fit, right? Okay, Dinky. Thank you. Okay, so we were up to example of first fit, best fit, and worst fit. Okay. Fine. So this is a list of free spaces which are available in the primary memory is with the operating system, and this is the memory layout of that instant of time. Okay, so that means that from address 0, 50 word size of block is free, then some memory is occupied. Then from address 300, 400 block word is free, then some number of words are occupied. Then from address 800, 200 block is free. So if the request is coming, let us say incoming process P1 is of size, let us say 100 words, right? So at P equal to 1, a new process arrives whose memory requirement is 100 words. Okay, so we'll see first according to the first fit. Okay, what happens in first fit? What happens in first fit, everyone? Roll number 134. Yes, Maulik? Okay, so assignment, the block is occupied by the process, the list which operating system is maintaining, which is a list of free block, will be updated. So from now, from location 400, 300 words block is free. Let us say we are having another process which is having memory requirement of 250 words. So according to first fit, where it will allocate this process P2? Am I audible, everyone? Okay, so my next process is process P2, which is having a memory requirement of 250 words. And this is the current memory layout. Okay, this is the list which is available with the operating system, which consists of list of free blocks. Okay, so now where this process P2 will be located? Yes, Dinky, you are right, at location 300, right? From location, let us say 400, it will allocate this process which is of P2. This is a process P2, and this is process P1 which is having 100 words requirement. P2 is having 250 words requirement, right? So now, how much size free block will be generated? How much size free block will be generated? Okay, so it will generate a block which is of 50 words only, right? So this is from address 650. Now 50 word block is available, right? So now operating system will change the list of free words that from location 650, 50 word block is available. Okay. So when there is a process whose memory requirement is 50 words, then it will allocate either from block 0 or from block which is at address 650. Okay, which is according to first fit. Right? Is it clear to you, everyone? Fine. So if I'm having the same scenario, and I want to allocate the process, okay, to the main memory, okay, with the current scenario, I'm writing here it again. So this is address, starting address from where the free block is available, and this is the size of block. From address 0, we are having a 50 words free block. From address 300, we are having 400 words free word. And from 800 location, we are having a block of 200 word which is free, right? And our memory layout is something like this. Okay, so you can consider that from rest of the words, it is the block are occupied. Okay, now there are three incoming process. The first process P1 is having memory requirement 100 words. A process P2 is having memory requirement 250 words. And another process which is having a process P3 whose memory requirement is just 50 words. Okay. Now you have to repeat this scenario according to the best fit. Right? What happens in best fit? The smallest hole which is large enough for the incoming process will be given to the incoming process. Right? So you have to repeat the same scenario but now using the best fit, not using the first fit. Okay. Note down these things and do it in your book. Okay, so P3 will be allocated at location 0. P2 will be allocated at location 300. Yes, right, Dinky? And P1 will be allocated at location 800. Yes. So this is right. Okay. Is it clear? So now I am giving you one question, right? You need to solve this question by your own. Okay, I'm writing the question here. So your question is, we are having a 16 KB memory and available space list is having a region, matlab starting address and size of the whole, right? So from address location 0000, we are having 2 KB space available. From location 1000, we are having 1 KB space available. This location are given in hex, right? So this is given in hexadecimal, okay? And this one is given in terms of bytes, right? From location 200, 2000, let us say, we are having a block of 512 byte is available. And from location 31FF, a block of 3 KB size is available, right? Now, the following sequence of allocation and deallocation request occurs. What is the sequence? The sequence is this is a time. The time is t plus 1, t plus 2, t plus 3, and t plus 4. At particular instant of time, some request is occurring, right? At t plus 1, size of block is allocated. This is allocation request, okay? That is 1K. T plus 2, another request comes, which is again an allocation request of for the process which is having a memory requirement of 2K, right? Then the next kind of request is address of block to be deallocated, right? So at t equal to 3, deallocation request comes. Okay, what deallocation says? Deallocation says that from location to DFF, deallocate the block which is of size 1K, right? So this is the size of block to be deallocated. right? So at t equal to 3, which request comes? Request comes from that, from location 2DFF, deallocate the block of size 1K. And then again from t equal to t plus 4, another request is coming to allocate a size of block which is of 1 KB. Right? So this is your current layout. Right? Now, what you need to determine? You need to determine the available space list after all these requests have been solved using first first fit allocation and by using a best fit allocation, right? This is your question. You have to solve it. What you need to determine? You determine the available space list first by using first fit and next by using best fit allocation. Okay, solve it right now. This question is clear? Is the question is clear, everyone? Yes or no? Write down. Yes, okay. So now I'm sharing it again. You're having 10 minutes to solve this question and then come up with the answer, okay? So I think Dinky and Jill has come up with the answers. Okay, what about others? It is according to first fit. Okay. Okay, fine. So I think it is clear, right? Okay, one more question and then we'll end this topic. Our next question is, we have 6 memory partitions of sizes 200 KB, 400 KB, 600 KB, 500 KB, 300 KB, and 250 KB. So these are 6 memory partitions available with us. Okay. These partitions are need to be allocated to 4 processes. Right? The processes are having size requirement. The P1 needs 357 KB. Okay, kilobytes. Okay, even though it is written in small case, it is a kilobyte. Okay, P2 needs 210 KB. P3 needs 468 KB. And P4 needs 491 KB. Okay, in that order. Matlab, first P1 comes, then P2 comes, then P3 comes, and then P4 comes. Okay, the processes are coming in order. Okay, if first fit algorithm is used, which partitions are not allocated to any process? You need to find out which partitions are not allocated to any process if the algorithm is first fit and if the algorithm is best fit. Okay, what is your question? You are having a layout of the memory that is having a 6 partitions. The partitions are of size 200, 400, 600, 500, 300, and 250 KB. These partitions are need to be allocated to 4 processes. These processes are coming in order. Okay. First P1 comes, then P2 comes, then P3 comes, and then P4 comes, and the memory requirement of all the algorithms are given, right? We need to find out that which block will not be allocated to any process if, okay, the question is reverse, which process will not be allocated to any partitions? Will not be allocated to any partitions if algorithm is first fit and if the algorithm is best fit. Okay. Read the question very carefully. I modified it. Okay, and the solution. Okay, so we'll ask for the solution in the next lecture. Okay, in best fit, all the processes will be allocated. Okay.
Ma'am, can you show the question again?
Yes, okay. The question is this. In best fit, all the processes will be allocated. Yes, Gautam is right. Yes, Fenil is also right. In best fit, all the processes will be allocated. But if you are going to use the first fit algorithm, then process which is of size 491 KB will not be allocated. Right? Is it so, everyone? Yes. Okay. So that is the answer. From next lecture onwards, we are going to start with very important topic of this session, which is segmentation and paging. Right? Jill, first question का answer already shared by Kashyap and I think Fenil and Dinky. Okay. So if you can see in the screen, it is shared by Dinky, Fenil, Jill, Kashyap also. Okay.